In this video, we're going to use the unit circle to estimate the sine, cosine, and tangent of each angle in radians. Our first angle is 0.6. Now notice, this is not 0.6 degrees, this is 0.6 radians. So what we need to recall is, what is the definition of an angle in radians? Well, we have theta in radians is equal to the arc length divided by the radius. But we're working with a unit circle where the radius is 1, so we get s over 1, and that reduces to s. So measuring an angle is the same as measuring the arc length around the outside of the circle. So in this diagram, it says that we have a unit circle with arc lengths labeled measured counterclockwise from 1, 0. So here's the point 1, 0. We're measuring counterclockwise. Notice that there's 6.28 or 2 pi radians in the whole circle. And so what we want to do is to locate an arc length of 0.6. So we go counterclockwise, get to 0.5. 0.6 corresponds with the tick mark right after that. So to represent the angle, we draw a ray from the origin and then rotate counterclockwise to that terminal ray, and we'll label the angle theta, where in this case theta is equal to 0.6. Our goal is to find the sine, cosine, and tangent of 0.6. So we need to recall our definitions. Up here it says that x is cosine theta, y is sine theta, and the one that's not written down is that y over x is equal to the tangent of theta. So in order to find these values, we just need to label the coordinates of the point on the unit circle. So if we drop a vertical to the x-axis, we can see that it corresponds with 0.8. And if we look across horizontally to the y-axis, we see that the y value is between 0.5 and 0.6. I'm just going to go ahead and round off to 0.6. So the sine of 0.6 is approximately the y-coordinate of our point, which is 0.6. The cosine of 0.6 is approximately the x-coordinate of our point, which is 0.8. And the tangent of 0.6 is the y-coordinate over the x-coordinate. So 0.6 over 0.8, and that reduces to 0.75. Now to check our results, we can use a scientific calculator. I'm going to use Desmos. So the first thing that I do is go to settings and make sure that the calculator is in radian mode, which it is. And then we can enter our trig function. So let me start with sine of 0.6. That rounds off to 0.6. Cosine of 0.6 rounds off to 0.8. And the tangent of 0.6 rounds off to 0.7. So we were a little bit off with the tangent function, and that's because we had approximated the sine and the cosine. But just from looking at the unit circle, I think we did pretty well. And we'll try part C next. What are the sine, cosine, and tangent of 3.5? So like we did before, we'll start at the point 1, 0. We'll measure counterclockwise until we get to 3.5. To see the angle, we'll draw a ray from the origin. We'll rotate counterclockwise from the positive x-axis. And this is our theta, where theta is equal to 3.5. In order to find the trigonometric function values, we need to label the point. It looks like the x-coordinate's approximately negative 0.9. And the y-coordinate, looking over at the y-axis, is approximately negative 0.4. So the sine of 3.5 is approximately our y-coordinate of negative 0.4. The cosine of 3.5 is approximately the x-coordinate of negative 0.9. And the tangent is the ratio of the y value to the x value. So you get negative 0.4 divided by negative 0.9, and that is approximately 0.4. A negative divided by a negative gives us a positive value. And once again, if we want to check the validity of our results, we can use the Desmos calculator. This time we have the sine of 3.5, which rounds off to negative 0.4. The cosine of 3.5, which rounds off to negative 0.9. And the tangent of 3.5, which rounds off to 0.4. So we did really well that time. I'll leave the other two as exercises. See if you can find the sine, cosine, and tangent of 2.3 and the sine, cosine, and tangent of 5.3.